Good afternoon. So today our topic of discussion is investment analysis. That means when we need to pre-evaluate the project, that whether the project is financially viable, we need some tools of financial management for investment analysis. Uh, how to change the slide? Sir? Right. Right. So the evaluation methods are classified into two categories. One is the if discounted cash flow method and non-discounted cash flow method. So you may ask that how we separate the discounted cash flow method and non-discounted cash flow method. It's easy. When there is no effect of interest, we straightway say that it is a non-discounted cash flow method. And the methods which we will study under non-discounted cash flow method are payback period and average rate of return, or simply ARR. There are number of methods under non-discounted cash flow. That is, it incorporates the effect of interest in the cash flow. So one most important method is the NPV method, or net present value. Profitability index method, it is an alternate model of discounted cash flow, and internal rate of return method. And there is also discounted payback period method, but for the time being we will discuss the payback period. That is these two methods of non-discounted cash flow, payback period and ARR, and NPV, as well as internal rate of return. Now, what is payback period? Payback period is the time required to recover the original cost of investment from the future cash flow. That means whenever a project is undertaken and they identify that this is the investment amount, this is the budget. Now, there is a time period within which the cost of investment can be recovered from the future generation of cash inflows, or simply the income. That means over successive years, whenever the income is generated, suppose the project lifetime is 5 years, but from the income generated, it is possible to recover the cost of investment within 3 years. So 3 years will be considered as the payback period. Now we go into the details. Now, payback period can be calculated simply by dividing the cost of investment by annual income after tax but before depreciation, the income generated per year, provided the cash flow should be uniform. That means you are getting the same amount every year, which is same. In that case, it is possible to use this formula to directly calculate the payback period. But the condition is that if the cash flows are non-uniform, if there is a condition that it is not necessary that every year an organization will earn the same amount as cash flow, which by which we can easily calculate the payback period. Now consider that the cash flows are non-uniform. In that case, we will use the cumulative cash flow methods and determine the payback period. There are two things. One is the payback period and the payback profitability. Payback profitability is calculated by earnings per year multiplied by the difference of working life and the payback period. Now let us consider this problem where we see that the cost of the machine for A is 1 lakh and that of B is 1,25,000. Their lifetimes are also different. Machine A is having the lifetime of 5 years and machine B 6 years. Now the pattern of cash inflow, that is the profit, which we say earning after tax but before depreciation, this is simply the profit generated. We see that for machine A it is non-uniform and for the machine B it is uniform. So if we compute the payback period for machine B, it is easy. You just divide the cost of the machine, that is 1,25,000 by the annual cash flow, that means 30,000. This will give you the payback period for machine B. But in case of machine A, we need to apply a different technique to calculate the payback period. In machine A, what we have done, that we have computed the cumulative earnings. Cumulative earnings, that means for first year this is 30,000, for the second year, since the earning is 40,000, the cumulative earnings is 30,000 plus 40,000, 70,000. Similarly, for the third year, it is 1,10,000, then 1,35,000 and so on. Now we need to determine the payback period for machine A. Now we see that the cost of investment for machine A is 1 lakh, and we observe that in second year 70,000 is already recovered. Since the cost of the machine 1 lakh is greater than 70,000, so we see that at the end of second year 70,000 is already recovered. Now at the end of third year the cash flow is 40,000 and the cumulative earnings is 1,10,000, which is exceeding the cost of the machine. So we can say that the payback period of machine A lies between 2 and 3. That means 2 plus fraction of third year, which will be required for recovering the cost of investment. Now we compute that 2 years is already taken to recover 70,000. So the balance which is left, it is 1 lakh minus 70,000, that is 30,000. So what fraction of third year will be taken for recovering this remaining amount, that is the 30,000, that is the balance amount. Now as per the pattern of cash flow, we see that 40,000 is earned at the third year. That means we can say that 40,000 is earned in 1 year. That means we are not saying the number of the year, but third year means the time which is taken to recover 40,000, it is 1 year. So if 30,000 be the cash flow, then what fraction of time is required to recover the same? So we simply divide 30,000 by 40,000. That means we use the unitary method, so that 0.75 year, 0.75 year, if we consider that 1 year comprised of 12 months, so 3/4 of the year will be, say, it will be 9 months. 0.75 of the year means 9 months. So the total payback period of machine A is 2 plus 0.75 or 2.75 years. That is 2, or we can say that 2 years, 9 months. Now we will compute the payback profitability. So this is the payback period computed for machine B. So from the formula, as we say that payback profitability is computed by multiplying the average earnings per year with the difference of lifetime and payback period. So for machine A, the average earnings, the total earnings for machine A is 1,50,000. So average earnings will be 1,50,000 divided by 5. So this amount, that is 50,000, multiplied by the difference of lifetime of machine A, that is 5 years, and 2.75, that is the payback period. So we get straight away 67,500. Similarly, the payback profitability computed for machine B is 30,000 multiplied by the difference of lifetime and payback period for machine B, that is 6 minus 4.17, it is equal to 54,900. Now the acceptance rejection rule, that means we have gone through a number of calculation computations. Now what will be the decision that need to be taken for the payback period whenever we are making a comparative analysis for machine A and B? Lower the payback period, more preferable is the investment. That means any investment, whenever we are computing a payback period which is lower than the other possible investment proposals, we shall accept that investment proposal having a lower payback period. So in our case, we see that for machine A, the payback period is 2.75 years, which is lower than that of machine B. Machine B is having a payback period of 4.17 years. So on the basis of payback period, we will select machine A over machine B. But whenever we are considering the criteria of payback profitability, it is just the reverse. Higher the payback profitability, more preferable is the machine. So in our case, we see that payback profitability for machine A, it is higher than that of payback profitability of machine B. So we accept machine A over machine B. So both the criteria cannot be simultaneously applicable. We can apply any one criteria, either payback period or payback profitability, for taking the investment decision. Next, this is another payback period method, another problem which we will work out through payback period. In this case, some data are provided. So from the given data, we need to calculate the earnings per year. What is the average earnings per year? So let us go to the next slide. So we see that the savings per annum for machine C, it is equal to 7,800. That means we are subtracting, that means we are calculating only the savings part, that is savings in indirect materials, savings in wages, savings in scrap. So the overall savings is 7,800. Similarly, for machine P, the total savings is 10,000. Now we need to, in order to calculate the average earnings per year, we need to deduct the costs. So what are the costs? So we just go through the previous data. Here only additional cost of maintenance, main, supervisor, this is only the cost part, and all the others are savings, components of savings. So from here we calculate the overall profit, that is annual profit before tax, by subtracting the total cost from the total savings. So from 7,800, whenever we are subtracting 2,000, we get 5,800 as profit before tax. Profit before tax means the tax is not yet deducted. As it is given that 50% of the earnings are to be deducted as tax, we are calculating 50% of 5,800, which is equal to 2,900. So the profit after tax is 2,900 since 50% is given. Similarly, after deducting the tax for machine P, we get the profit after tax 3,500. Now we will determine the payback period. Now in this case, since the cash flows are not given separately year wise, so we should assume that the cash flow to be uniform over the time horizon. That means over the lifetime the cash flow is said to be uniform, as because yearly cash flows are not given as in the previous problem. So we shall assume that this cash flow, that is earnings after tax, this cash flow will be applicable for all successive years, which is uniform by nature. So straight away we calculate the payback period by dividing the cost of investment with the profit after tax. So we get 5.17 years as payback period for machine C and 8.58 years as the payback period for machine P. Now let us calculate the payback profitability. So we use the payback profitability for machine C, which is equal to 2,407. That means we are multiplying the profit after tax with the difference of lifetime of the machine and payback period. So which is equal to 2,407. And similarly, we get 11,920 as payback profitability for machine P. Now here, that which machine should be accepted and which machine should be rejected, or say which investment proposal should be accepted and which investment proposal should be rejected. Now let us consider payback period to be the criteria. With respect to payback period, since machine C is having the lower payback period with respect to machine P, machine C will be preferred. But in case of payback profitability, if it is considered as the criteria of selection, then machine P yields more payback profitability with respect to machine C. So in that respect, we shall consider machine P. So both the criteria, as I told you, although as from the given data in the previous problem we have seen that for the machine payback period as per that means whenever we are using payback period as criteria, the same machine is selected if we are using payback profitability as criteria. But here we see there is a contradiction. That means if we select payback period, we should prefer machine C, and if we select payback profitability, here machine P will be preferred. So this is the payback period. Now we will discuss on the methods with discounted cash flow. So net present value. So net present value, whenever we are using the effect of interest on the cash flow, that means we are discounting the cash flows in the 0th year, we are using the present value analysis on future cash flow. So under this method, all future net cash flows are expressed in terms of present value by using appropriate rate of discount return. Now the rate of discount completely depends upon the expectation of the businessman. That means to earn rupee 1 at the end of year 1 must invest somewhat less than rupees 1 today. So for rupee 1 tomorrow have some present value. That means if we consider 100 rupees in today's date, after 5 years it will be with subject to interest, the amount will increase. But the monetary amount is increasing but the value is decreasing. That means here if we are considering rupees 100 today, which becomes 120 or 150 after 5 years, this amount is, the figure is increasing, although we say the value is increasing, the value is not exactly increasing. It is the time value of money where the value is decreasing, isn't it? Now let us work out with the formula. That means here we need to compute the discounting factor. Now let us say that what is discounting factor and what is compounding factor. Compounding factor means we know the present, we need to determine the future. Say an amount of rupees 100 after 5 years at 10% rate of interest. So here we determine the compounding factor by using this formula 1 plus I whole to the power n, where I is the rate of interest and n is the number of years. That means we are converting present to future. But in our case, since the term is net present value, that means we are using present value analysis. That means we are making a back calculation of future cash flows which are discounted to the 0th year or the current year. That means we have to know what is the future amount and what is the amount of the same in today's date. That we need to determine through present value analysis. So we are using the discounting factor, which is inverse of the compounding factor. That means we have written 1 plus I whole to the power n to be the compounding factor, and discounting factor is just the inverse, that is 1 divided by 1 plus I whole to the power n, which converts f is the future value of the net cash flow, which converts the future value into its present equivalent. Now this is the cash flow diagram. How the discounting takes place, we are representing in a graphical form. Say 1, 2, 3, 4, these are the successive years. 0 means this is the time of investment. That means in which year we are going to invest the amount. And these are the future cash flow, that is CIF1, CIF2, CIF3 and CIFN. These are the cash inflows over successive years from at the end of year 1, at the end of year 2, 3, n respectively. Now our objective is to determine the what is the net amount if this amount is invested, that is COF0, it is the amount that need to be invested. Now these need to be compared with the present equivalent of all future cash flows, so that we can come into a conclusion that whether this investment is financially viable or it is profitable. Now what we do, we are converting all the cash flows. That means CIF1, cash inflow means, let me tell you that inflows are generally profit, revenues, that means which comes in the business. And COF, cash outflow means which goes out of the business. Any investment, any expenses, costs, all come under cash outflow. So we need to compare the inflow and outflow at the 0th year. That means until and unless we convert all the cash flows in the 0th year, it is meaningless to compare them. So that is the use, that means we have to scale down. Now the thing is that the present equivalent of all future, that means when we are converting the cash flow, that is CIF1, into its 0th year, that means CIF1 is the expected cash flow at the end of year 1. So when we are converting it into the 0th year, we get the present value to be CIF1 by 1 plus I whole to the power 1. Why whole to the power 1? Because this happens after the end of year 1. So whenever we are converting, we are multiplying CIF1 with the discounting factor 1 by 1 plus I whole to the power 1. Similarly, for CF2, we will multiply CIF2 into 1 by 1 plus I square. For CIF3, we will multiply it by 1 by 1 plus I whole cube. And for the last one, that is CIFN, we will multiply by 1 by 1 plus I whole to the power n. So this is the present value of cash inflow, only the inflow part. Now if we are facing the question that what will be the present value of cash outflow, that is COF0. COF0, since it happens at the 0th year, it is itself a present value. Or if you want to mathematically convert it, you multiply it with the discounting factor 1 by 1 plus I raised to the power 0. So obviously the discounting factor will be 1. So you will get the same result, COF0. So it does not need to be converted as because it is itself a present value since it happens in the 0th year. Now, when we need to determine the NPV, we take the difference of summation PVCIF and summation PVCOF. That means we shall take the difference of present value of all cash flows and the present value of all cash outflow. For the sake of simplicity, we have taken only a single cash outflow at the 0th year. But when there will be cash outflow in successive years, we have to convert all such cash flows into its 0th year by multiplying it with the equivalent discounting factor. So here we can apply the criteria. That means if we now the conclusion part, that means what decision should be taken if this difference is positive, if this difference is negative, if this difference is 0, what decision should be taken? Now NPV, if it gives a negative result, that means when we find that the present value of cash outflow is greater than the present value of cash inflow, in this case the proposal will not be accepted because it will generate a loss. Whatever you are investing, you are not supposed to recover that investment from the cash inflows or from the revenues or profit generated over successive years. So here we shouldn't accept that proposal with negative NPV. But if NPV is positive, the proposal can be accepted. That means in that case, the summation of cash inflows is greater than the summation of cash outflow. So in that case, you can expect a profit, or you can also recover the cost of investment. In addition, you can expect some profit. Now let us consider this numerical problem. So here two investment proposal. Now one thing I should mention whenever we are making comparative analysis for two investment proposals using NPV procedure. Can we write in the board?
So I need to select the board. Select the pen.
Let us consider project X. Suppose the investment of project X be IX. The rate, that is interest rate, I am using small I suffix x, and let us consider the time to be nx. Similarly, for investment Y, I am using IY, small I suffix y, and ny. Now whenever we are making comparative analysis by using NPV criteria among the three parameters which determines the value of the NPV, at least two has to be equal. That means if we are comparing x and y, either IY and IX, small IX and small IY, that means investment of the two projects has to be equal and the rate has to be equal. Maybe the year that may not be equal. So in that case, we can go for the NPV rule. It may happen that the rate of both the projects are equal and the time horizon of both the projects are equal. So even if the investment is different, we can proceed. So we will apply this rule whenever we are solving this problem for a comparative analysis with NPV. Now in this problem, both the investment X and Y have they are having 20 crore. That means the value of the investment for both the cases X and Y is 20 crore. And the study period is 4 years. It is also same. The end of year cash flows are provided and let us see whether the interest rate is same. As per the given information, the rate of interest should be taken as 12% per annum. That means this is same. That means all three are same. Two can be same, that means at least two can be same, but if all are same, then also we can take go for the NPV procedure. Now we have used the present, we have calculated the present value by multiplying the discounting factor with the respective cash flow. Now let me say that why we are saying this one minus sign. Actually, we are making the calculation in one shot. That means we are including all the cash flows. 0th year, this 20 crore, it is a cash outflow. Since this is the investment, we are using a negative sign. For outflow, we are using, since as per the calculation of NPV, we need to subtract the present value of cash inflow from the present value. Sorry, we have to subtract the present value of cash outflow from the present value of cash inflow. So here we are taking a negative sign initially. All these are cash. So this is basically a cash outflow. But all these are cash inflow. Now we calculate the discounting factor. As I told you, if you calculate the discounting factor for 0th year, it will be equal to 1. For the successive years, that means at the end of 1, 2, 3 and 4, we have computed the discounting factor. So discounting factor, as I told you, this has to be computed by 1 plus I whole to the power n. So we have computed the discounting factor. After computing the discounting factor, we are multiplying with the respective cash flow. That means this is the discounting factor for year 1. So we are multiplying 0.89286 with 10 crore. So this gives you 8.93. Similarly, the discounting factor at the second year is 0.79719. Actually here, let me tell you that the value of I is 12% and the value of n we have to change accordingly. That means whenever we are calculating for 0th year, first year, second year, third year and so on, we have to change the value of n, but the value 1 plus I, this is constant. Okay, so we are getting this value as discounting factor and we are getting the present value of cash inflow by multiplying the cash inflow with its respective discounting factor. After calculating the present value of cash inflow for X and Y, we get 10.39 as the NPV. That means minus 20 plus 8.93 plus 11.96 plus 5.69 plus 3.81 equals to 10.39. In this case also we obtained 15.13 crore. Now the question is that which investment proposal is better? Now as we see that both the NPV are positive. So the NPV with higher positive value, that means this one, this has to be accepted over investment X. That means from the NPV criteria we are getting both the NPV to be positive, so we accept the higher positive value, which is in case of investment Y. So we accept investment Y with respect to investment X. So this is how we use the NPV rule to evaluate the investment proposals. আচ্ছা ইংলিশ করে দেবো এগুলো এটা দিয়ে না
ডিলিট ডিলিট ডিলিট
আচ্ছা ডাইরেক্ট Now internal rate of return. Internal rate of return, it is a limiting case. That means when the present value of cash inflow is equal to present value of cash outflow, or say simply NPV is equal to 0, the rate at which this relation is established, we say that rate to be the internal rate of return. So internal rate of return is the rate at which NPV is equal to 0, or we alternately say that the present value of cash inflow is equal to present value of cash outflow. In this case, that means we use the, that means what is the importance of determining IRR? IRR is a limiting case which equals to which equals the present value of cash inflow and present value of cash outflow. So whenever any organization is determining the rate, as we have discussed in the previous slide, that it is determined by the business owner, the rate. So they determine the rate of return, that means the rate of interest, which is less than IRR. Until and unless they determine what is the IRR at which the business breaks even, then they cannot able to determine this rate, because whenever they are using the rate, they need to determine the NPV to say that whether the investment proposal is profitable or not. So that is the question why they determine the IRR. Now IRR, since there are n number of years, so solving a n degree polynomial, it is very much critical. So here the only method of calculating IRR is trial and error method. We need to determine the rate, that is the higher trial rate and the lower trial rate, and after determining the higher trial rate and lower trial rate, we use the method of interpolation, that is IL plus NPV IL divided by difference of NPV IL and NPV IH multiplied by the difference of rate. Now the question is, what is lower trial rate and what is higher trial rate? What is the significance? How we will determine that which one is lower trial rate and which one is higher trial rate? So we need to determine this by trial and error method. Now let us go into a problem. Now in this case, already one trial rate is given, but in practical scenario this rate will be not provided. So you have to start with 10%, then 11%, then 12%, and so on. Now the tactics, that how far you should go for the calculation, that means where we should stop, that need to be determined. Initially, whatever rate is assumed, either 10% or 20%, you need to calculate the NPV using that particular rate. If it is positive, if you get a positive NPV, in order to lower the value of NPV, you have to increase the rate. Now increase means, let us check by 1% increase. If you find still it is positive, you increase the rate by 2%, and then check if it is still positive, and after increasing the rate, if you find that the NPV is negative, that rate should be considered as higher trial rate. So the rate of interest has an inverse relationship with the NPV. In this case, or since the 21% is already given, we are calculating the NPV at 21%. At 21%, we get the NPV to be 58. That means it is a positive figure. So when NPV is positive, we need to increase the rate so that the NPV will approach towards negative. So let us increase the rate by 1%. Let us take 22% and recalculate the NPV. So after calculating the NPV at 22%, we see that this figure is negative. So with difference of 1% increment, we see that we get NPV with alternate sign. That means for 21% it is positive, and for 22% it is negative. More less is the difference between higher and lower trial rate, more precise is the result of IR. So here, as we see that with 1% increment, we get a positive NPV and a negative NPV. So we shall consider 21% to be the lower trial rate and 22% to be the higher trial rate. And then we apply the method of interpolation. We substitute the value in the method of interpolation to calculate the IRR. Since this is positive and this is negative, we can say that the IRR lies between 21% and 22%. Now we need to determine the exact figure of IRR by using the method of interpolation. So in this method, we substitute the value of IL, IH, NPV IL and NPV IH in the expression, and we get 21.155% as the value of IR. Now one thing we have taken, let us see that in 21% we obtained a positive figure, so we have to increase the rate. Had this figure been negative, suppose you started with 22%, you started with 22% and you got a negative, whatever rate you were taking, you got a negative figure. In that case, please keep in mind that you have to decrease the rate so that the NPV will approach towards positive from negative. So in that case, you assume you decrease the rate by 1% or 2%, whatever, and see whether you are getting a positive NPV. So you should consider the two extreme values, that is lower and higher trial rate, whenever you are getting the NPV with different sign with 1% increment. So here actually, since we are applying the method of interpolation to achieve more precise result, the difference of rate should be 1%. So thank you very much. আচ্ছা এবার পজ করব